In this lesson, we will be covering using similarity in measurement. Um, so what is basically the application of similarity in area, in volume, and also in applying to drawings and to the maps. Um, One thing you need to remember is drawings or maps are usually smaller than the real object. Unless if you're talking about very small creatures, if you want to make a drawing of a very small insect, then the drawing could be larger. But generally, drawings and maps are smaller than the actual um, size. The other thing is we know how to find the scale factor for lengths. If you know the scale factor for lengths, you need to square it to get the scale factor for area, and you need to cube it to get the scale factor for volume. It will all be clear once we go through these examples. Example 1. The figure shows the map of a block of land. On the map, AB is 4 centimeter. The actual size of AB is 20 meter. Find the following. So this is a block of land, a map of a block of land. What we know about this is when you measure this AB on the map, it is 4 centimeters from A to B. But we know that the actual size of that AB represents is 20 meters. So what they're asking is find the scale factor first, and then if the actual size of CD, that's the CD, is 30 meters, so that's the actual size of CD. How long it will be on the drawing or on the map? How long it should be here? If it was 30 meters in real life. All right, we want to find the scale factor. So we got to see what is the actual size and how does it compare to the drawing. So for AB, they told us it is 20 meters in real life and 4 centimeters on the drawing. So we need to divide the actual size by the size of that part in the drawing. But remember, this is in meters and this is in centimeters. So we got to make them the same unit. So 20 meters is 2000 centimeters. You got to times it by 100 to change from meter to centimeter. All right, now both of them are in centimeters, 2000 centimeters and 4 centimeters. So 2000 divided by 4. Now the units are the same, we can drop. We can drop the unit and divide. So 2000 divided by 4 is 500. So the scale factor is 500. So that means any measurement you take on the map, you need to times it by 500 to arrive at the actual size that it represents. So now in part 2, they are saying that CD is 30 meters, how long it will be on the drawing. So 30 meters, we can again change it to centimeters, that becomes 3000 centimeters. That is the actual size. But we said that we need to divide it by the scale factor to see how long it will be on the drawing. So 3000 divided by 500 is 6. So CD will be 6 centimeter on the drawing. Example 2, the two triangles shown are similar. The area of the larger triangle is 45 square centimeters, find the area of the smaller triangle. So you got this larger triangle and this smaller triangle. They are telling us that they are similar, so we don't need to prove it. And they told us that this one has an area of 45 square meter. Find the area of this smaller one. All right, the first thing for us is to find the scale factor. And to find the scale factor, you got to compare the corresponding or matching sides. This side from the big triangle, 6 meter one, matches the 2 meter one from the smaller one. How do we know that? Both of them are opposite, two equal angles. This dot here and this dot here means that these angles are equal. And the sides opposite to them will be corresponding sides. So 6 meter and 2 meter are corresponding sides. Now, to find the scale factor, we need to divide the corresponding sides. So 6 divided by 2 is 3. So the scale factor is 3. Now, what we did, we got the scale factor, but scale factor is for length. Here we are dealing with area. And if you got the scale factor for length, you need to square it to arrive at the scale factor for area. So that was 3 for length, so we need to square it. 3 squared is 9. Now this is the scale factor for area. That means that the area of this larger triangle is 9 times the area of this smaller triangle. So they are told us this is 45, then we need to divide by the scale factor of area to find the area of the smaller one. So 45 divided by 9 gives us 5. So the area of the smaller triangles is 5 square meters. Why square meters? Because the larger one was given in square meters. That is for example 2. Now we do an example for volume. Two cylinders are similar. So we're talking about two cylinders that are similar. The smaller one has a radius of 4 meter and the larger one has a radius of 20 meter. All right, so like any other similar shapes, we need to compare the corresponding lengths. Here, the two radii, the radius of the first one and the radius of the second one will be the corresponding lengths. Or they could have given us the height of the first one and the height of the second one. Then heights will be the corresponding one. Or it could be diameter. So anyhow, here we have the radius, the two radii. So we need to compare them. In other words, we need to divide the larger one by the smaller one to get the scale factor for radius or length. Remember, radius is length. So 20 was for the larger one and 4 meter was for the smaller one. So 20 divided by 4 is 5. 5 is the scale factor for length, as we said. Now, to arrive at the scale factor for volume, this time you need to cube it. So 5 cube, and that gives you 125. Then, that is the ratio of the two volumes, or the scale factor of the volumes. So because they have given us the smaller cylinder, we need to times by the scale factor for volume to find the volume of the larger one. So 10 times 125 gives us 1250 cubic meter. That is how we use similarity to find the area or volume or compare the maps and the actual size. One more word on why, for example, when scale factor for length is 3, we need to square it to find the scale factor for area. Because remember that area, for example, if you look at a triangle, it is true for any shape, but if you look at a triangle, so the formula for area is area equals to half times base times height. Then when you're comparing two triangles, so let's say the scale factor is, 8. Then that means for the larger triangle, the base is 8 times larger, and also the height is 8 times larger. So we're talking about two eights here times together. That becomes 64. That's why we say that to go from the scale factor for length to scale factor for area, you need to square it, because area is made of two lengths, one base and one height. And similarly, we can make a reason for the volume. That brings us to the end of this lesson. Thank you very much for your attention.